Fiberglass is one of those materials that quietly holds the modern world together. You don't usually notice it, but it's everywhere around you, hiding in the walls of your home, beneath the paint of your car, inside the hull of boats, and even in the wind turbines spinning on distant hills. It's strong but light, rigid yet flexible, and tough enough to survive decades of heat, cold, water, and vibration. Most people think of fiberglass as just fluffy insulation or a rough, itchy material behind drywall, but that's only a tiny part of its story. What makes fiberglass truly fascinating is how something as ordinary as sand is transformed into one of the most useful materials ever created, and how that transformation has shaped the way we build, travel, and live. The story of fiberglass begins with one of the most common substances on Earth: silica sand. This is the same kind of sand you'd find on a beach, but in industrial production, it is purified and carefully blended with materials like limestone, soda ash, and small amounts of other minerals. These extra ingredients change the way the glass melts and cools, making it better suited for being pulled into long, thin fibers instead of forming solid sheets or bottles. Once the ingredients are measured and mixed, they are poured into a massive furnace that operates at temperatures so high they would melt most metals. Inside, the mixture becomes a glowing pool of molten glass, thick like honey and hot enough to shine with a bright orange light. At this stage, it looks nothing like the final product, but this liquid glass is the foundation of everything fiberglass will become. From the furnace, the molten glass flows toward a piece of equipment called a bushing. This is a metal plate filled with hundreds or even thousands of tiny holes, each one no wider than a pin. As the molten glass passes through these openings, gravity and mechanical pulling stretch it into incredibly thin strands. These strands are so fine that many of them are thinner than a human hair, yet they are made of the same basic material as a window pane or a glass bottle. As the glass leaves the bushing, it cools rapidly, turning solid almost instantly, while still being drawn into long, continuous filaments. The speed at which these filaments are pulled determines how thick or thin they become, and that thickness is carefully controlled depending on what the fibers will be used for later. Almost immediately after the fibers form, they are coated with a special chemical mixture called sizing. This might sound like a small detail, but it's one of the most important steps in the entire process. Bare glass fibers are fragile and tend to rub against each other, which can cause them to break or create fine dust. The sizing protects the fibers from damage, reduces static electricity, and prepares their surface so they will bond well with resins or other materials later. Think of it like a protective jacket that also acts as glue in future stages. Once coated, the fibers are gathered together into bundles and wound onto large spools that look like enormous rolls of thread. At this point, the glass has become fiberglass, ready to be transformed into whatever form is needed. Some of these spooled fibers are woven together just like fabric. They pass through looms that interlace them into sheets, creating fiberglass cloth that looks a bit like woven fabric but feels stiff and slightly rough. This woven fiberglass is incredibly strong for its weight and is often used when durability and structural integrity are needed. Other fibers are chopped into short pieces, creating what's called chopped strand. These tiny fragments can be mixed into liquids like resin to create molded parts and reinforced plastics. The same basic glass fibers can become soft and fluffy or hard and rigid, depending on how they are processed next, which is part of what makes fiberglass so incredibly versatile. One of the most familiar forms of fiberglass is insulation, often called fiberglass wool or glass wool. To make this, the fibers are fed into machines that blast them with high-speed air and heat, breaking them apart and tangling them together into a light, airy mass. The result looks a bit like cotton candy or wool, but it's made entirely of microscopic glass strands. This fluffy structure traps pockets of air, and trapped air is one of the best natural insulators. That's why fiberglass insulation is so effective at keeping heat inside in winter and outside in summer. It also absorbs sound, which is why rooms lined with fiberglass tend to be quieter and less echo-filled. When you see pink or yellow rolls of insulation in a hardware store, you're looking at billions of tiny glass fibers working together to create comfort and energy efficiency. Another major form of fiberglass is used in what are called composites. where the glass fibers are combined with resins such as polyester, vinyl ester, or epoxy. When liquid resin soaks into fiberglass cloth or chopped fibers and then hardens, it creates a material known as fiberglass reinforced plastic. This composite is far stronger than plastic alone and far lighter than most metals. It can be molded into complex shapes, cured into solid forms, and engineered to handle incredible stress. That's why it shows up in everything from boat hulls and car panels to airplane parts and industrial tanks. A fiberglass boat, for example, can survive years in salt water without rusting, rotting, or losing its structural strength, something that would quickly destroy untreated metal or wood. In construction, fiberglass has become a quiet revolution. Beyond insulation, it is used in wall panels, roofing, pipes, doors, and even decorative architectural features. Fiberglass panels can be molded to look like stone, wood, or metal while being far lighter and more resistant to weather. They don't corrode, they don't warp, and they don't attract insects. In harsh environments, like coastal regions or industrial plants, fiberglass components often outlast traditional materials by decades. This durability saves money and resources over time, even if the upfront cost is sometimes higher. Transportation is another area where fiberglass has made a huge impact. Every kilogram removed from a car, truck, or airplane means better fuel efficiency and lower emissions. Fiberglass parts help manufacturers reduce weight without sacrificing safety or strength. You'll find it in hoods, body panels, interior components, and even leaf springs in some vehicles. In boats, fiberglass is almost everywhere, from hulls and decks to masts and storage compartments. It provides strength, smoothness, and resistance to water in a way that few other materials can match. Sports and recreation have also been transformed by fiberglass. Fishing rods made with fiberglass bend smoothly without snapping, allowing anglers to feel even the slightest tug on their line. Skis and snowboards use fiberglass layers to create the perfect balance between stiffness and flexibility, helping athletes maintain control at high speeds. Surfboards, kayaks, helmets, and even golf club shafts all rely on fiberglass to deliver performance that would be impossible with older materials. These products don't just last longer, they perform better, making sports safer and more enjoyable. On a much larger scale, fiberglass plays a vital role in modern infrastructure and renewable energy. Wind turbine blades are a perfect example. They must be enormous, sometimes longer than a football field, yet light enough to spin smoothly and strong enough to withstand years of powerful winds. Fiberglass composites make that possible. Without them, many of the wind farms that now supply clean energy to millions of homes simply couldn't exist. Fiberglass is also used in bridges, pipes, chemical storage tanks, and even reinforcing structures in buildings, where its resistance to corrosion and fatigue offers a longer service life than steel in many situations. Of course, fiberglass is not without its challenges. The tiny glass fibers can irritate the skin and lungs, which is why installers and factory workers wear protective clothing, gloves, and masks. Modern manufacturing techniques and coatings have reduced these risks significantly, but safety is still a key part of working with fiberglass. Recycling is another hurdle. Because fiberglass is a composite of glass and resin, it can't be melted down and reused in the same way as metal or pure plastic. However, new technologies are being developed to grind, separate, and reuse fiberglass waste, turning old blades, boats, and panels into materials for cement, asphalt, and new composites. What makes fiberglass so remarkable is not just what it is, but what it represents. It is a perfect example of human ingenuity, taking one of the simplest materials on Earth and turning it into something that supports skyscrapers, moves vehicles, generates electricity, and makes our homes more comfortable. It bridges the gap between nature and technology, between sand and science. Every strand of fiberglass carries the story of heat, chemistry, and careful engineering, all working together to create something far greater than the sum of its parts. The next time you walk into a quiet, well-insulated room, ride in a smooth, lightweight car, or see a wind turbine turning on the horizon, remember that there's a good chance fiberglass is playing a role behind the scenes. It's not flashy. It doesn't get much attention. But it is one of the true workhorses of the modern world, quietly shaping how we live, travel, and build for the future. If you enjoyed traveling through the hidden world of fiberglass with us, there are countless more stories waiting just beneath the surface of everyday life. From the materials in your home to the technology in your pocket, each one has a history that's just as fascinating. Be sure to like this video, subscribe to the channel, and keep exploring with us as we continue to uncover the surprising stories woven into the simple things that surround us every day.